different types of solutions. So if we start on this first example, I have a visual here that is representing an equation, and I am just going to start off, and since I don't know the weight of these red kettlebells, I'm going to mark them as x variables. They're unknowns. And then I'm going to make this into a picture equation. So 4x's plus 22 is equal to 74 plus 2x. And then I'm actually just going to write this as an equation sentence. 4x plus 22 is equal to 74 plus 2x. This is a variables on both sides equation. So just like we finished working on, I'm going to first start by isolating my variables onto one side. To do that, I'm going to move my 2x just because it is the smaller of the two numbers. When I do that, I am left with 2x plus 22 is equal to 74. I'm now going to isolate my x variable all by itself. So I'm going to first do that by subtracting 22 from both sides. That leaves me with 2x is equal to 52. And then lastly, I'm going to divide both sides by 2, giving me my final answer of x is equal to 26. This is the type of solutions that we are used to. I am given an equation where x is on one side and then a number is on the other side, and this is what we call a one solution. What this means is that for this particular equation, only one number will satisfy this equation, making it a true statement. So 26 is the only number that we could plug in for those x's to make both sides balance. Moving on to our second example, this is going to be a new type of solution that you have not worked with yet this year. So again, I'm going to go through and I'm going to mark my red kettlebells as x variables because we do not know how much they weigh. I'm just going to make this a picture equation. And then I'm going to write it out as an equation itself. 4x plus 25 is equal to 40 plus 4x. Just like before, our goal is to get variables on the same side. So I'm going to subtract 4x from both sides. But you should notice that when that happens, we actually cancel out all of our x variables. That leaves me with 25 is equal to 40. We need to take a second and think, is this a true statement? Is 25 equal to 40? And we all know that it is not. So this is a not true statement. So when this happens and it's not true, this is what we call a no solution. The reason we call it no solution is that no matter what number I plug in for x, my two sides will never be balanced to each other and it will never make a true statement. So there is no possible solution or number that would make this equation true. Moving on to our third example. Just like before, I'm going to mark up my picture, making my unknowns into x's and making a picture equation. And then I'm going to write it out as 3x plus 32 is equal to 32 plus 3x. I'm going to isolate my variables onto one side, so I'm going to subtract 3x from both sides. And just like the one before, our x's cancel out. I am left with 32 is equal to 32 though this time. So I have the same number set equal to itself, which I know is true. 32 is the same or equivalent to 32. So this is a true statement, unlike before or above. So if we go through and our variables cancel out and it gives us a true statement, we call this a many or an infinite solution. The reason we call it many or infinite solutions is that there are multiple or infinite numbers that we can plug in for our x variable that would make this a balanced or true statement. So if I plugged in 1 for all of my x's, since there are the same amount of x's on both sides, it would still stay balanced. So now that we have talked about the different types of solutions, let's move on to the next side, and we're going to do 3 of these together. So if we're looking at number 1, I'm just going to start off by drawing a line right down my equation at my equal sign. And this is a variables on both sides. I have x's on both sides of my equal sign. So I'm going to start off by subtracting my smaller of the 2 numbers. So I'm going to subtract 2x from both sides. That leaves me with 5x plus 18 is equal to 63. This is now a 2-step equation. So I am going to first undo any addition or subtraction by inverse operations. So I'm going to get rid of this plus 18 by subtracting 18 from both sides, leaving me with 5x is equal to 45. And then lastly, I'm going to divide both sides by 5. That leaves me with an answer of x is equal to 5. So based on the front of our notes, is this going to be a 1, a many, or a no solution? This is going to be a 1 solution. This equation must have 5 equal to x in order for both sides to be balanced and true. Let's move on to our second example. So I'm going to draw my line down my center. And I have a lot of things going on in this one. So our first thing is I'm going to identify some like terms. I'm going to start off by combining like terms on the same side. So I'm going to leave my left side alone. But on this right side, I can combine 7x and negative 4x to give me 3x. And then I can combine my 15 and my negative 13 to get an answer of a positive 2. I want to move variables onto the same side. So I'm going to subtract 3x from both sides. When I do this, all of my variables cancel out. So I'm going to see what statement I am left with. We are left with 2 is equal to 2. I want you guys to take a second and think about if this is a true or a false statement. This is a true statement. So is this going to be a 1, a many, or a no solution? It is going to be many, or you can also call it infinite. Oops, solution. So no matter what I plug in for x, our equation is forever going to be balanced. Alrighty, let's move on to number 3, and then I'm going to have you guys do the rest on your own. Actually, I'm going to do number 4. On this one, I chose to do number 4 instead, is just because we have that distribution going on, so I want to make sure that we can get some of that review in. So since I have distribution, I always want to start with that. So I'm going to first by multiplying my outside term by my inside term. So 3 times 2x gives me 6x. 3 times a negative 8 gives me a negative 24. And then I'm just going to rewrite this side of the equation because we have not done anything to it yet. I'm now going to circle my like terms and box in my constants. I'm going to stick to combining like terms on the same side. So on this side, I still have 6x minus 24. And then on this side, I'm going to combine my 4x and my 2x to get a 6x over here. And then I'm going to get negative 17 minus 7 more is going to give me a negative 24. I'm going to subtract 6x from both sides to get my variables on the same side. Just like before, my x's cancel out, and we need to see if my statement below is true or false. I'm given negative 24 is equal to negative 24, which is true, which means just like the one we did above, this is going to be a mini solutions. Alrighty, so as a reminder, if your x is set equal to one number, that is a one solution. If your x's cancel out and makes a true statement, that is going to be a mini or an infinite solution. And if your x's cancel out and you're left with an untrue statement like we have up above, that would be a no solution. If you have any questions, feel free to reach out to one of us teachers, but I would like you to try to finish the rest of the examples below on your own. Thank you.